Hello everybody, this is Sumadhur Shakya. Welcome to this learning session. I made this video to help and facilitate your learning. I hope you enjoy the video and find the information presented in this video as useful. Let the learning begin. Thanks. Hi, welcome to this video of project management, making network diagrams. I'll be using activity on nodes as an example. In this video, we will calculate expected time of completion, variance, standard deviation, and then using forward pass we will calculate early start and early finish time, and using backward pass we will calculate late start and late finish time, and also calculate slack 1 and slack 2. That'll be helpful for making a Gantt chart later on. And so let's get started for the network diagram using both PERT and CPM method. Okay. So let's say we are given the optimistic time, most likely time, and the pessimistic time. Now, in order to calculate the expected time of completion, it's given by A plus 4M plus B divided by 6. So it's essentially 4 times the most likelihood plus A plus B divided by 6. So like a weighted average. Okay, so let's get started. So equals to, pay attention to the parentheses, A plus 4 times M plus B close parentheses divided by 6, and that's going to be the same for all of them. Now I'm going to use the color coding such that these are all the calculated values. Therefore I'm going to color them differently, and I'll change them again in a minute, but let's fix this. Okay, that's sufficient enough. Now the next thing we want to calculate is the variance. Now variance is defined by, let me first variance. Now variance is defined by B minus A divided by 6 squared. Okay, so let's get started with this. Equals to parentheses B minus A divided by 6 raised to the power 2, and it's going to be the same for all of them. Again, I'm going to color this slightly different, and okay, now let's get rid of this. The standard deviation is going to be square root of this raised to the power 0.5. Now the key thing to keep in mind is that when need be, we can do the algebraic sum of the variance but not the standard deviation, and that's going to be the key component later on, and I'll show it too. So this is the standard deviation. Okay, now at this point in time we have sufficient information to make the network diagram. So I'm going to go ahead and make a rough diagram by hand first, before we start calculating all the possible combination using critical path method, the CPM method. Okay, so the first thing I'm going to do is make A, B, C. Now, given the immediate predecessor information, D comes after C, right? So D comes after C, and then B and D comes after E. Oh, sorry, E has a predecessor of B and D, so I'm gonna write E. Okay, so B and D. Now F comes after A and E, so F comes after A and E. G comes after A and E. G comes after A and E. H comes after F. H comes after F. Now we are making an assumption that the intersecting line do not allow for activity G to happen after F. Okay, now that's an assumption for simplification. H comes after F. We are done with that. I comes after G. I comes after G. J comes after C. J comes after C. K comes after H and I. K comes after H and I. Now, this is a rough diagram to complete the CPM method for permutation and combination for activity on nodes. Okay, the other form is activity on arrows, for which you'll have to draw a different node for start and end. But this is a rough example. Now, if we were to use insert and shapes from here, you can rearrange this. But for now, this serves my purpose for CPM methodology to calculate all the possible permutation combination. So for example, one path could be from A, G, I, and K. The other form could be A, F, H, K. The third path can be B, E, F, H, K, and so on. So we will calculate all of those paths. So to give you an example, we will start typing it up and add the corresponding numbers. Okay. So I'm going to slide this to the right so it's visible, and then bring this CPM method and all the combination thereafter over here. Okay. Or let's just start typing in here. The first one is going to be A hyphen G hyphen I hyphen K. Now this is just a norm wherein hyphen represents the arcs and all the other alphabet name represents the name of the activities in sequence. So then we are going to do A plus G plus I plus K. Similarly, we will do this for all the other possible combinations. So now we have all the possible combination and permutations for the possible paths that we could see from this activity on node diagram. Okay, now the maximum time taken is by the path C, D, E, F, H, K. So that's C. Okay, let me show this to you. So, oops. Maximum path is this one. So out of all of the permutation combination, the path C, D, E, F, H, K is going to take the longest. Okay, so by definition, that is the critical path. So C, D, E, F, H, and K. If any of these activities is delayed, the whole project will get delayed. Any or all other sequence of activities will get done before this time, or the path on the critical path, or the activities on critical path. So by definition, the longest sequence of all the activities is the critical path. All activities that are now non-critical, for example, A, J, G, I, and so on, will all get done, and including B, by the time this sequence of C, D, E, F, H, K is done. This is what will determine the completion of the whole project. Okay. Now, let's go ahead and zoom in on these individual activities. By tradition or norm, single activity A, if you were to zoom in, we will represent activity A by name. Then there would be expected time of completion written here. There would be an early start here, early finish here, late start, oops, late start and late finish. This is how you break down a single activity. Now, in order to keep it simple, I'm going to convert this graph into the shapes, and then also make up in the cells, and then you start to calculate how we come up with early start and early finish using forward pass, late start and late finish using the backwards pass. Okay, so if you were to use this form of insert and then any of the shapes, then this is how the activity of node diagram looks like, where you can draw and then draw arrows and name these as activity A and so on. Okay, now in this case I've highlighted the critical path activities, and each of these numbers are coming from what we calculated. Okay, now this is only required for understanding it graphically. It helps us visualize. So C, D, E, F, H, K is the critical path, just the way we calculated here, and I'm going to highlight this as well so that it's obvious. And we do not get confused as we keep on calculating more and more numbers. Now, to make these activities a little bit more detailed, I'm going to use the cells within the spreadsheet and start calculating early start and early finish. Although it's easier, I mean, once you understand the concept, to start calculating early start and early finish and calculate them here. But prior to that, I'm going to color code my activities on the critical path differently. Okay, so I'm going to use C, D, E, F, H, K. So let's highlight these differently so then we do not make mistakes, because accuracy is important. Okay, so I'm going to use, let's say, these colors, okay, to highlight the activities on critical path. At this point in time, I am also going to calculate the variance for the activities on critical path. So I'm going to pick up the variance. You remember, mathematically we cannot add the standard deviation, but we can add the variance. So I'm going to pick up the variance of this plus this plus this plus this, H and K. So that gives me a variance of 5.56. And accordingly, now the standard deviation is going to be the square root of this. So this is the standard deviation for the whole project. Now I need not calculate about all the others, because I'm only worried about the activities on critical path or the critical path method. I mean, whenever we will calculate what is the probability of completing this in a certain time period. Okay, so let's go ahead and calculate. Let's say if we know the due date, let's say the due date is around 45 weeks. Okay, now I forgot to mention this in the beginning, but let's say all of these times are given in weeks as well. Okay, now the formula for calculating the z-score is due date minus expected date divided by the standard deviation. Okay, so just to refresh your memory, I mean, you can find this anywhere on the internet. So the z-score is therefore for this method is going to be parenthesis 45 weeks minus 42 weeks divided by the standard deviation. That's why we calculated this. That was the whole idea. Now, given this z-score, the probability of completing this project in 45 weeks or less is going to be norm S I N V, or you can read it from the table. But I'm going to use, equals to norm S I N V of 1.1. That's how much standard deviation on the standard table it comes out to be. Where did I made the mistake? Okay. Norm S, normal standard distribution of 1.13. Okay. So the probability of completing this project in 45 weeks or less is going to be 87%. Okay, now let me highlight this. Again, the terminology is important. The probability of completing this project in 45 weeks or less is 87%. Now let's go ahead and use the PERT methodology to calculate the early start and early finish. So I'm going to expand this network diagram within the spreadsheet for the sake of simplicity, so that it's easier to understand this. Okay. So expanded all of these individual drawings into more detailed traditional way of calculating and representing early start and early finish time. So for example, J, I'm going to make this equals to the activity time that we completed, okay, and do this for all of them. So for J, expected time is this. For G, it's 2.17, and then for F, it's going to be, let's see, 10, and do this for all the other activities, okay. And keeping things safer for my own self, I'm going to color code C, D, E, F, H, and K, and highlight them as the activities on critical path. Okay. Now let's see, what is the earliest I can start the activity C? Now the earliest I can start activity C is time 0. So I'm gonna say 0. This is what is called as forward pass. Okay. So we are going from start to finish of the project. So this is the time 0, and this is the time of 42 point something that we calculated in here, 42.3. Okay, so the earliest start time for activity C is 0. Therefore, the earliest finish time, if we just to remind you, this is the early start time, the early finish time, late start time, or the latest finish time, and then the expected time of completion for each of the activity. Just this is the general norm for all of these activities that we have here. Now, if when we have to calculate the activities on critical, the earliest we can finish for activity C is going to be equals to the earliest we can start plus the time it takes to complete that activity. So this is going to be the same for all of them. Now, before I fill in those, let's calculate the second activity on this critical path. So it's C, D, E, F, H, K. So let me draw that for a minute. So then we stay on path. So it's C, D, E, F, H, and then K. So after connecting all of these activities, just like the last activity on node diagram that we drew for rough work for calculating all the sequence for CPM. Now let's get started with the forward pass. Forward, okay, pass. So we will start first on all the activities that are on critical path. So we already did this, starting with 0, the earliest start time. Now the earliest we can finish this activity is 0 plus 8, so that gives us 8. Now the earliest finish time of activity C is going to be the earliest that we can start activity D. So that's going to be this. Now the moment we know earliest start time of D, which is 8 weeks, D itself takes 7 weeks, so the earliest we can finish this activity is D plus 7. Okay. Now the moment we know the earliest finish time of D, that gives us the earliest we can start activity E. Okay. Now the moment we know the earliest start time for activity E, the earliest we can finish this activity is 15 plus 4 weeks. If the earliest finish time for E is 19, that's going to be same as we can start
activity F. Okay, now if we can start this on 19th week, then we can finish this by 10 plus 19. Similarly, it's going to be the earliest start time for H is going to be 29 weeks, and the earliest finish time is going to be 29 plus 6 for activity H. Therefore, the earliest start time is going to be the earliest finish time of the preceding activity, and the earliest finish time for K is 35 plus the activity time itself. And that's 42.3. Double check. Yes, we did not skip any cells, and so on. Now, this helped us calculate earliest start time and earliest finish time. Now, a better idea is to have this somewhere calculated in a table format, because it'll be helpful for us to make Gantt chart later on. I did this only for explanation purpose, so then you know how these things are getting calculated. Now, using backward pass, we will start from the finish of the activities towards the start. The forward pass was, if this was to be all of the cooking activities, then this is whatever you start first, going with the activity, the sequence of activities that's going to take the longest, and you proceed from left to right on this diagram. Now, the backward pass is going to assume that you have a deadline by which all the food has to be ready by a certain time period at this time. So let's say if this was to be 5 p.m., then you have to start from there, 5 p.m. of a certain date, and then start backwards, because if each of these activities are going to take certain weeks or certain hours, then you better start early. Now, when it comes to the activities on non-critical path, the activity A and B, here, they're again going to be 0 and 0. And the formula is again going to be the earliest you can finish B is going to be 0 plus 4, the time itself. So I'm going to fill it up for A as well. Now, when it comes to activities on non-critical path, this follows a critical path. So the earliest I can start J is again going to be the earliest finish time of the preceding activity on critical path. Similarly, the earliest I can finish J is going to be 8 plus 16. Okay. Now, when it comes to activity G, it is being followed by activity on critical path. Therefore, it is safe to say that it's going to be the earliest finish time of the preceding activity, but the textbook will say the maximum of earliest finish time of all the preceding activity. In this case, there's only one preceding activity, A, and the next activity is E. So let me double check. Yeah, for the G, it's A and E. So out of the two, I'm going to take equals to maximum of preceding activities, A and E. Therefore, E is going to be the deciding number. So either you can do it this way, or you can just directly say, because this is the activity on critical path, the earliest you can start G is when the activity E is done. Okay, so either way, whichever works for you. Now, once you have the earliest start time, the earliest finish time for G is going to be 19 plus 2.17. Okay, now once I'm done with the G, the earliest finish time of G is going to give me the early start time for I. The moment I have the start time, I can also calculate the finish time. That completes our forward pass. For the backward pass, we will start from right to left, assuming that we have a deadline of completing this project in 42.33 days. So either you can take it from here, or just to be safe, I'm going to start from the CPM method. Okay. Now, at this time, the late finish time, the latest I have to finish this activity K is 42.3. Therefore, the latest I have to start this activity, knowing that this activity itself takes 7.3 weeks, is going to be, come on, 1, 2, there. So the latest I have to start this is by 35th week, because I have to finish this by 42.3 weeks. The activity itself is going to take 7.3. Therefore, I better start this by 35th week. Now, again, following the critical path, if this is the latest I have to start, and late finish, I should have labeled this early start and early finish. Now this goes for all the other activities as well. Now if I know the late start time for activity K, this is going to be equals to the latest start time of K. So now I know the late finish time of H. The moment I get that number, I can use the same formula of latest finish minus the activity time for H. Okay. Now if I know the late start time of H, that gives me the late finish time for the preceding activity on critical path, which is 29. Therefore, I will also get to calculate the late start time of F. Now, here onwards, I will follow the critical path. So the late start time of F is going to be equals to the late finish time of E. If that gets known, then I can calculate the latest I have to start activity E, knowing that itself it takes 4 weeks. Keep on following the critical path. The late start time of E is going to be the late finish time for D. If the latest I have to finish D is by 15th week, then the latest I have to start the D is by 8th week, which is 15 minus 7 here. Now, if the latest I have to start activity D is by 8 weeks, then I need to start activity C by 8th week. And that gives me, if C itself is going to take 0, then 8 weeks, then I better start at 0. Okay, so now knowing all of this, backwards pass, we followed the critical path for late finish and late start. Okay, once you get the late start, the of this activity is going to be equals to the late finish of the preceding activity. This is equals to this, and then 19, for example, for activity F is 29 minus 10. That gives you 19. This 19 is equals to this 19. 19 minus 4 gives you 15. 15 is equals to this late finish of D. 15 minus 7 gives you 8. This 8 is equals to this 8. 8 minus 8 gives you 0. Okay. Now, once you are done with all of these activities on critical path, then let's start with activities on non-critical path. Okay. Yeah. So from here onwards, this is the last activity. If this is the latest I have to start for activity K, then the latest finish time for activity I, even though it is non-critical, has to be equals to the late start of the activity on critical path prior to that. Now, once I know that I have to finish this, the latest I have to procrastinate, or I can procrastinate activity I, is 35 weeks. 35 minus 9, that's going to give me the latest start time. Okay, so equals to 35 minus 9, and so on. Once I get this latest start time for activity I, that's going to be equals to the late finish time, and then the latest I have to start activity G, therefore is going to be 26 minus 2, 0.17, that's going to give you 23. Now from this onwards, we need not calculate the late start time for E, because that's on the critical path and we're already done with it. The only other two activities we are left with is A and B. Now, when it comes to A, we have a choice. They're going from right to left, right? So we are going in this direction, backward pass. So let's talk about A first. So A comes after G or after F, right? In this arrow or this arrow. Now, when it comes to the late start time for activity A, the latest we have to start, it's either 19 or 23. So in order not to mess up the whole project, this will become the deciding criteria. So the latest you have to start activity A then becomes equals to 19. Okay, because this is the activity on critical path when you have to choose between G and F for deciding the late finish time of activity A. In textbook, they might say minimum of all the activities that are afterwards of this activity A. So you can either calculate minimum of 23.83 and 19. So that'll give you the same answer. That's the textbook formula. But because you're already done drawing this, it makes life a little easier. Okay. And once you have the latest finish time of A, the late start time for activity A is going to be 19 minus 4. 19 minus 4. Now when it comes to activity B, it is followed by activity E, and that's it. So activity B is only connected to activity E. I just wanted to make sure that I drew these arrows correctly. Okay. So latest I have to finish this is when the following activity on critical path has to start. So late finish time of B is going to be exactly equals to late start time of this. So after that, the latest I can start this activity is going to be 11th week. 15 minus 4, that's 11. Okay. Now we'll collect all of these numbers in the table format as well. Okay. So early start, early finish, and then late start and late finish. Okay. So now either you can collect these numbers from here if you're confident about these, or you can calculate from here as well. Okay. Again, I'm going to show this to you. You can either use this graph to calculate the earliest and late start times using forward pass, starting from 0 and then 8. If you know the latest start time, let me bring this right here. The easiest thing to do is 0, 0, 0. These are the earliest start time for A, B, and C. Okay, so the earliest you can start activity A, B, and C is 0. You've already calculated A, B, and C as 0. Okay, so wherever you want to pick up the numbers from, it's going to be the same. The earliest finish time is going to be 0 plus the time of activity itself, and that is true for all of them, except that we haven't punched in the earliest start time of all the other activities. The activity, let me hide these columns for now. So then it's hide. You can also hide these two for now. And we are working on these. Okay, now the earliest we can start B, we already calculated, is 8. The earliest we can start E is 15. The earliest we can start, why there are 3 decimals? Okay, we'll fix that. The earliest I can start F is going to be 19. We already calculated this, so I'm going to pick up from here. The earliest I can start G is 19. H is 29. I is 21.17. And J is, where is J? The earliest start time for J is 8. And last for K is 35. Okay. Now I'm confident about the earliest finish time. Why? It's always going to be earliest start time plus the activity time. So this formula stays true no matter what. Let me highlight these activities on critical path again, so then they are different from the rest of them. Now these two were done using the forward pass. Okay, forward pass. Now for the latest finish time, I'll have to pick up from these numbers, but the late start time is going to be the late finish time minus the time of activities themselves. Okay, so and I should be able to copy this down. Oops, I better keep it as number for now. It's showing wrong numbers, but let's say forward pass, I'm going to start from the K equals to 42.33, and then J we already calculated. Oh, I forgot to calculate J. For the J, this has to be done. Since there is no following activity after J, it has to be equals to 42.3 when the whole project has to be completed. And the latest I can start J is going to be equals to 42 minus 16.3. That's 26. Now this will not impact the late start time of preceding activity, which is C. Why? Because the late finish time of this is going to be decided by the activity on critical path. So minimum of 26 or 8. So that's going to be 8. Now once you have 8 minus 8, you get 0 here. So equals to 8 minus 8. So I forgot these two activities. I apologize. Now for J, late finish time is 42. For I, 35. For H, it's where's H? H, it's 35. Then it's G. So for G, it's 26. Then prior to G is F equals to F here, F, and then E is 19, D is 15, C is 8, B is 15, and A is 19. Now, here's the fun part. As a self-check, if all the other things were done correctly, then when we calculate slack 1 and slack 2, so slack 1 and then slack 2, now they're defined as late start minus early start. So this is going to be LS minus ES, and the slack 2 is defined as late finish minus early finish. Okay, so let me do this the other way around. So slack 1 and slack 2. So yeah, slack 1, slack 2. This is late start minus early start, and this is late finish minus early finish. So let me type that in: late finish minus early finish. Yeah. So equals to late start minus early start, and late finish minus early finish. Now what you will notice is that all the activities on critical path will have a slack of 0. Okay. So this is also true to the definition, because activities on critical path should not have any slack. Otherwise, I mean, if we can delay them further, then something else may elongate the longest sequence of activities. So this is your self-check. If all the activities you on slack 1 and slack 2 come out to be exactly equal of 0, then you are on the right track. If they are not, then you did something wrong and you need to cross-check what happened here. Now, if, let's say, assuming that we do not have access to the Microsoft project, at this point in time, I will rearrange my activities from the earliest start time. So earliest start time, I can pick this up and let's say paste it right here. And I can pick up the expected time of completion, paste them as values, also the activities over here, and either of the slacks. So because in my case they came out to be exactly equal, that means whatever we did here so far seems to be correct. Now once I have this, okay, then oops, I forgot to select this. Then I can use this to make a graph. So let me bring this down here so it's all visible, and unhide. Okay, so at this point in time, I'm going to use this to make a Gantt chart out of this. The easiest one to do this is using horizontal bar chart, one after the other. Okay, so I'm going to do this. Serves my purpose. First thing I'm going to do is format this and make this A through K instead of K through A. So categories in reverse order. Then the next thing I'm going to do is hide all the early start times. Okay, so that'll give an illusion that all these activities are happening in order. Okay, so no fail. Now just to highlight, I'm going to say C, D. So I'm going to have to do this one at a time, I guess. Solid, and then C, D, E, F, H, and then K. Slack is fine. Now let me also try to label these. So when it comes to labeling, let's say add data labels. Now it shows the activities, the time of expected time of completion for each of these activities, and I'm satisfied with that. So this is what you'll call as a Gantt chart. So when it comes to the audience that you will explain to the audience, you will only represent not so many of these numbers, but only this one will go on the PowerPoint to present it to the audience. Okay, only this much. So first slide is going to be this one, wherein you'll say out of all the sequence of activities, C, D, E, F, and H, K are the activities that are on critical path and should not be messed with and cannot get delayed, otherwise it affects the whole project. And um, uh, or this chart where you will say the probability of completing this project in certain XYZ number of weeks is this much. So using these two numbers, so whatever your deadline is, you're looking at 44 weeks, 46 weeks, or 47 weeks, and the corresponding number that you calculated, and then you show this on a Gantt chart. This is sufficient. You will not show any of these numbers. If you do have access to Microsoft Project or Smartsheets and so on, or other project management software, some of these numbers you may never have to calculate by yourself. Instead of calculating early start and early finish time, you may be allocating these activities to either personnel or in terms of cost or in terms of dates. For example, a new deadline might come up wherein activity G has to be finished by a certain time frame in the future. So instead of starting from scratch from left to right, you will only right click activity G and say that this activity has to be finished by a certain date. And hence, because there are so many moving numbers, none of these calculations are difficult to calculate. But because they are sequential and dependent on the activities before and after them, having access to project management software does help our life big time. Okay, so even if you don't have access to it within the spreadsheet, you can certainly get up to the point of Gantt chart and also be able to calculate what is the probability of completing a project given the optimistic, most likely, and pessimistic times. What is the standard deviation, what is the probability of completing a project, and should not bid for it, and what is the Gantt chart. So then you can visualize it. But again, the first thing I would always recommend is after calculating expected time and variance and standard deviation is that you draw the network diagram by hand, somewhere on copy on pen and paper, or somewhere in Excel by touch pen and pad or something. And after that, you start calculating the CPM method. Once you're done with that, then proceed with the early start time and early finish time on a proper network diagram, and using the forward pass from start to finish. Then using backward pass, you calculate late start and late finish time. So these are calculated using backward pass from the end of the project minus the activity time, and again follow the activities on critical path first, then the non-activities, then the activities that are not critical, then calculate slack 1 and slack 2. Both of them should come out to be exactly same, and then calculate the Gantt chart at the end. Okay, so that's the sequence, the general sequence. Okay, I hope you find this tutorial useful. Yeah, stay happy, stay healthy. Bye for now.